How do we find the ideal pool size for the thread pool? Well, like most of the answers in computer science, the answer to this question as well is that it depends. However, it's worth discussing what it depends on. So let's get started. Imagine that you have a CPU intensive task which needs to be executed. Please note that in Java, one thread is one OS level thread. So if your CPU has 4 cores, then at maximum you could execute 4 tasks in parallel at once. So on a hardware which can only support up to 4 cores, creating hundreds of threads won't help if they are CPU intensive. In fact, it leads to a performance degradation. Let's focus more on why there is a performance degradation. When you have 100 threads to run your CPU intensive task, then all such threads will try their best to get their pie of the time allocation with the CPU. When this time slicing happens beyond a certain threshold, the expense of content switching overpowers the benefit we get from making use of the multithreading. So lots of threads contesting for CPU time is counterproductive, and in such a scenario, having too many threads is not a good idea. What we can do rather is have the same number of threads as the number of cores in your CPU. But please note that having created the same number of threads as the number of cores in your CPU does not ensure that all the cores will be running your threads only. Some of the cores will be utilized by other tasks and OS level processes as well. So how can we do this? Let's see a quick code example. In the executor service package, let's create this class. Let's call this as CPU intensive task. So let's create a task class and maybe let's call this as CPU task. It implements a runnable. Let's override the run method. And all it does is it prints some message like some CPU intensive task being done by the and thread dot current thread dot get name. Let's write the main method. In the main method, first we will try to get the number of the cores, and we can do so by making use of the runtime. So runtime dot get runtime dot available processors. Now let's create the executor service. Call this as service executors dot new fixed thread pool, and it could accept the number of cores as the number of threads it wants to create. Let's print a message for debug purposes. So created thread pool with cores. Next, let's execute our task. So let's say I want to execute 20 tasks and service.execute a new CPU task. Let's run this and see the output. Here is the output. So created thread pool with 14 cores. So my machine has 14 cores, and what it does is it says like some CPU intensive task being done by thread 1, thread 2, thread 10, thread 14, thread 14. So what we say is it has created 14 threads, which is the number of cores, and then those 14 threads are being used to execute the 20 tasks that we want to execute. So now let's learn about the other type of task. So there is another type of task which is IO intensive. Such IO intensive tasks are inherently fire and forget in nature. This is because IO operations such as reading from files or making network calls often involve waiting for external resources to respond. During this waiting period, the CPU is idle, and having more threads allows other tasks to execute while one thread is waiting for the IO operation to complete. However, here as well it's not recommended to go crazy with the countless number of threads. Rather, the more sane approach is to experiment with thread pool sizes. This will help you to find the optimal balance between concurrency and resource utilization. So to summarize, there is no single answer for the question of what's the ideal thread pool size. What you could do instead is analyze your task patterns and based on their type, utilize a combination of the above mentioned approaches.